The TRIZ 40 Inventive Principles. Genrich Altshuller, creator of the theory of inventive problem-solving, better known by its Russian acronym TRIZ, analyzed thousands of patents and identified a group of 40 techniques that inventors used successfully to solve problems across different fields. To inspire new inventors in their problem-solving, I created this video illustrating one of these principles. Principle 19. Periodic action. Instead of continuous action, use periodic or pulsating actions. For example, pulse-modulated cooling. This system uses nozzles, which are driven with a pulse-width modulated signal, optimizing corner temperature.
Crack-sensitive steel grades like AHSS of the second and third generation require width-adjustable secondary cooling to avoid potential overcooling of the slab corners and consequently corner cracks. With the current solution, the zones are split into center and margin strips across the casting direction with known advantages and challenges. With margins completely off, the temperature increase near the corner is too high. With margins completely on, the temperature of the corner itself is too low. Dynajet Flex takes the discretization of cooling zones to the next level. By using water-only nozzles, which are driven with a pulse-width modulated signal, it's possible to increase the turn-down ratio compared to air mist systems. This leads to optimized corner temperature. Depending on the strand width, the nozzles can be dynamically adjusted in order to provide homogeneous temperature distribution. The water supply of the nozzle is repeatedly switched on and off, ensuring that the desired cooling intensity is directly proportional to the duty cycle. The nozzles are perfectly optimized to guarantee a homogeneous, constant spray pattern, without any trade-off between an extension of the control range and good spray pattern uniformity. During manufacturing, every single Dynajet Flex nozzle is individually tested and coded before delivery. Every nozzle can be precisely tracked throughout its entire life cycle. The Dynajet Flex system has significant metallurgical advantages compared to air mist systems. Thanks to the higher turn-down ratio, any overcooling of the slab corners, as well as of the regions adjacent to the corners, can be avoided, thus reducing the risk of surface defects.
If an action is already periodic, change the periodic magnitude or frequency. For example, SolidState RF Oven. Regular microwave ovens operate at a fixed frequency. SolidState RF ovens can change their frequency to cook dissimilar foods evenly.
Although our kitchens and appliances have significantly changed in recent times, the fundamentals of how we cook our food hasn't. Today, there is a new cooking appliance revolutionizing the kitchen industry, which uses an advanced technology that can specifically tune the amount of energy it delivers depending on what food is being cooked. This technology is known as solid-state RF energy, which uses semiconductors to create and amplify RF energy, thoroughly cooking a food item. This heating method has enormous advantages over those found in your standard cooking appliances, like the stovetop, conventional oven, and microwave. For example, you can tune the frequency and power to heat this frozen pizza evenly to the exact temperature needed, and more quickly than conventional cooking appliances. Users can even perfectly cook a complete dinner all on the same plate at the same time. Solid-state RF energy can adaptively create, control, and deliver precise amounts of energy during operation. This is essential to enable increased automation and intelligent cooking. Gone are the days of monitoring oven temperatures and times. Just let your solid-state RF energy cooking appliance take care of everything. But the kitchen is just the beginning. RF energy is now being developed for advanced plasma lighting in horticulture, cutting-edge spark plug replacement for higher automotive fuel efficiency, and complex medical devices for cardiac ablation and cancer treatment, where precision is obviously paramount. We are telling you this because we are the RF Energy Alliance, an organization dedicated to the standardization, promotion, and adoption of this new technology. There are so many more possibilities with this exciting technology. If you have an idea on what process to power with RF or know how to do it, we want you to join us to help advance today's applications as well as drive future RF energy innovations together with the other stakeholders in this technology realm. Visit us at rfenergy.org to learn more.
Use pauses between actions to perform a different action. For example, SelfSanitizing Bathroom. This prototype is designed to sanitize the bathroom surfaces with UV light between uses.
This might look like Virgin Atlantic's newest super hip lighting scheme, but it's actually Boeing's prototype self-cleaning bathroom. That glow isn't mood lighting. It's an ultraviolet light that can zap 99.99% of germs your fellow flyers leave behind. When you close the door behind you, 2 sets of UV lights will turn on and disinfect the whole tiny room in just 3 seconds. For extra protection, the faucet, soap dispenser, hand dryer, and toilet seat will all be hands-free. In between flights, airline crews will still manually clean the lavatory, since there are some messes no amount of sunlight can tackle. If you're hoping to get bronzed on your way to the Bahamas, though, you're out of luck. Boeing's UV rays aren't the kind you see in tanning salons. And they should only turn on when the lav is unoccupied. So maybe your middle seat isn't going to get bigger anytime soon, but at least your time on that other seat should be a little more pleasant.
Share this video and add your examples of this inventive principle in the comments below. Periodic action. Instead of continuous action, use periodic or pulsating actions. If an action is already periodic, change the periodic magnitude or frequency. Use pauses between actions to perform a different action.